everyone, thanks for watching. In this video, I'll explain what it means for a chemical reaction to be reversible. Remember from our last video that chemical reactions happen when the reactant particles collide. As long as those collisions have enough energy and the proper orientation, this can cause bonds to break and the atoms to rearrange. We saw this where an NO, nitrogen monoxide, collides with O3, ozone. The particles are moving around, they collide with each other, and this oxygen atom breaks off, reattaches to the nitrogen, making our products NO2 and O2. This video will go one step further and ask the question, what would happen if this reaction was taking place inside a closed container? Here, this rectangle represents the closed container. Really, all this means is that these products that we just made, the NO2 and the O2, they can't escape. And if they can't escape, they're going to continue to bounce around inside that container. And it would make sense then that eventually the NO2 will collide with an O2. And if that collision happens, the oxygen that attached to my nitrogen will detach from the nitrogen and instead attach to the other two oxygens again. What's really taking place here is that the products we just made have turned back into the reactants NO and O3 one more time. And this happens for some reactions. If the product particles collide with each other, they can turn back into the reactant particles again. There's a name for this type of reaction. It's called a reversible reaction. So let's bring back my closed container and have a slightly more realistic view of what's happening with this reversible reaction. So we saw how it works with just one single NO and one single O3. But in real life, reactions don't happen with just one of each reactant. There's many particles. So here my closed container now is slightly more realistic. I've got some NOs and some O3s, but I've also got some products, some NO2s and some O2s. So we're assuming some time has passed and these reactants have started to produce some of these products. Now inside this container, the true visual here is that all of these particles are moving around, and if they're all moving, then sometimes an NO collides with an O3, and the NO and the O3 will produce the products NO2 and O2. So that's happening. That is also called a forward reaction because it's written in this typical left to right forward direction. But also in this container, I've got NO2s and O2s, and sometimes they'll be colliding with each other. And like we saw before, if an NO2 collides with an O2, it's going to turn back into the reactants NO and O3. Since this is the reverse of the reaction, the way it's written here, we call that the reverse reaction. And it's important to realize that for reversible reactions, both the forward and the reverse directions are happening simultaneously. Now at first this might seem kind of annoying and make you think for reversible reactions you have to write it one direction and then also write the reverse of that every single time you write this chemical equation. Luckily you don't have to write the reaction twice. Even though it can happen both directions, we typically still just write the reaction in one direction, but instead use a special arrow. There's 3 different versions of this special arrow you could see, indicating that it goes forward and also reverse at the same time. So for reversible reactions, you can expect to see, instead of an arrow that moves only in the forward direction, this special forward and reverse arrow. That concludes this video on reversible reactions. Here's a brief summary.